Hello guys, what's up? Ah, Today we want to talk about dimension. Last class, I said dimension is just like a method to confirm that truly derived quantity are from fundamental quantity. I released a video on fundamental quantity, and if you don't forget, I said these are the basic quantities accepted by science. Now, today we want to talk about dimension. And remember, I told you that this dimension is just like how derived quantities are actually being derived from fundamental. Now, one of these, I told you that apart from those seven in fundamental, any other quantity you see in physics belong to derived quantity. Now, to confirm that they are all derived from fundamental, let me just prove it. Number one, let's talk about area. Area is a derived quantity. It's not among the fundamental, definitely it's a derived. Area, what do you need to solve dimension, to work on dimension? You need the formula of the quantities. That's a basic thing, that's the first thing. You need the formulas. What are the formulas of area? The area is length and breadth. And don't forget in my video, the one I released, I said anytime you are measuring distance, that means you measure distance between two graphs. If you measure breadth, you measure distance between two graphs, 2 points. Sorry, you measure distance between 2 points. Separation. If you can see, I said separation between 2 points. And separation in my video, I said it is L. Then times L. Dimensionally, area is equal to L squared. So if the question asks you, actually you cannot see this one in Django, but if they ask you what is the dimension of the area, the dimension is L. The dimension is just like a method of representing the quantity with what? With letter of fundamentals. That's all. So this is it. And the unit here is what? Remember, I said the unit of length is meter, and this is meter square. Another thing apart from this is let's check volume. 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 So what's the formula for volume? Volume is length. Length times what? Length times breadth. Let me write it. Length times breadth times height. Either you are measuring the length, you measure the breadth, you measure the height. What are you measuring? You are measuring separation. And I said separation is length, which is distance, which is L. So we use L times L. It means your breadth is separation L. Your height is separation L. So if you multiply their L cube, and the unit here is meter cube. So this is the dimension of the volume. Apart from this, let's move on. So let's talk about speed. What about speed? What is the dimension of speed? Both speed and velocity, they have the same dimension. Don't forget, they have the same dimension, meaning that this dimension must be the same for volume, for velocity, and what? And speed. Now, what is the formula? That's the first thing. If you want to solve dimension, I told you, you need formula. The formula for speed is what? Distance over time. And if it is for velocity, it's going to be the displacement over time. And when talking about distance, distance means you are measuring the what? The separation between two gaps. That means L. If we talk about displacement, it's going to be the distance between two gaps, which is L, separation. So here we have the L times, sorry, divided by time, and this is LT minus 1. So the dimension of speed of velocity is L per time, which is the unit is meter. Remember, the unit of L is meter and time is second in class, and that's all. So let's see acceleration. Acceleration acceleration. The formula of acceleration is what? Is velocity over time. And you know your velocity already, which is the same thing as speed over time. As what? As LT minus U. Remember, it's going to be velocity or speed over time. And you said here that your velocity dimensionally is L per t. So therefore L per t then divided by t. If you solve this thing mathematically, you have LT minus 1. Then this long division is divided by, then we have T1. So if you do this one mathematically, if you compare the indices, you have L, T is common to both sides. You pick one T according to the law of indices. You pick one T, then because you have division there, you subtract the power. So this one will have a T minus 1, then minus, this minus is now division. Change the division change to minus, then 1. So if you solve this, you have L T. Let me write it here. So we have, let me write it here. I'm still on acceleration. So this one will now be, let me write it on here. Acceleration now. Acceleration will now be what? Will now be velocity divided by time. Velocity divided by time. So what is velocity? Velocity is Lt minus 1, and this is t. So here we have Lt minus 1, then divided by t1. So if you solve this mathematically, t is common to both. You pick one t according to law of indices, and division will change to minus according to the law of indices. So it's going to be minus 1, then minus, that division has changed to minus, then 1. You have Lt minus 2. So this is the dimension of acceleration. Now the unit here is meter per second square. And that is how they got the unit. Apart from this, let's talk about force. Force, what is the formula for force? Force, you need to ask yourself. Force is what? Mass times acceleration. Can you see mass in fundamental? Basically, yes. That means the dimension of mass is F. Now, can you see acceleration there? The answer is no. So, but you've calculated the acceleration dimensionally to be L t minus 2 input, right? This one will now be m L t minus 2. So, this is the answer. Do you understand that? So, apart from this, let's check another one. Let's talk about pressure. So, pressure is equal to force over area. And what is force dimensionally? You don't need to calculate it again. You have it here. M L T minus 2. Then divided by what is your area? Your area is L square. Remember your area is the first one we did. So we have what? M L T minus 2. Then this non-division is divided by L2. So at the end of the day, this one will be M. L is here, L is here. There is one here. So this division will change to minus. It's going to be L1, then minus. It has become minus, then 2. Because you take LL. You understand? You take one L according to the law of indices. When base is common, you pick one. And you add the power or you subtract the power depending on the what? Depending on the sign. So we have T minus 2. So if you solve this thing now, at the end of the day, you have your what? You have your, at the end of the day, you have your M L minus 1, then T minus 2. So that's the answer for the pressure. For the what? For the pressure. Let's see next one. Density. Density. Ask yourself that question. What is the formula of density? The density formula is what? Mass over volume. Can you see mass in dimension? Basically, yes. That means the dimension of mass is M. Can you see volume there? The answer is no. Then what is now the dimension of volume you calculated before? It is what? It is L cube. So therefore, dimensionally, density is M per L cube, which is this ML minus 3. I hope you understand. Now let's see another one before we go. Let's talk about momentum. Momentum. Momentum is what? Momentum is what? Dimensionally. Formula, sorry. Mass times velocity. So, can you see mass in fundamental? Sure. The fundamental are the dimensions of mass is m. But can you see velocity? No. But you've calculated it to be Lt minus 2. So, if you solve it, you have mLt minus 2. And that's all. So, if they ask you what is the dimension of moment, sorry, moment. Let me say moment. Moment have the same dimension as energy. So moment, energy, work. You can see all these bar. You can see all these three bar. They have the same dimension. You understand? Their formula here is force times distance. All these three have this formula. So the dimension, can you see fundamental? F in fundamental? No. So the dimension of F, which you've calculated before, is mlt minus 2. And what is the dimension of S, distance? That's the gap between 2 points. That's separation. That's L. So times L. You have nl2 t minus 2. So this is what? This is energy. So they may ask you to calculate what? The dimension of power. Power now. Power is what? Power is equal to work over time. Yeah, that's the formula. So work, what is the dimension of work? You've calculated it before. To be what? To be ml2 t minus 2 then t. You understand? Dimensionally now, if we solve this, ml2 t minus 2, then this long division divided by t per 1. So you can solve this thing mathematically by saying ml2, because you have t this side, you have t this side, you pick one according to law of indices, t. And the law of indices says that if they have division in between, the division will change to minus. That means you subtract the power. So we have minus 2 on top of this. This one becomes minus, then 1. So in here we have ml2 t minus 3. So that's the dimension of power. Now let me give you one more. Let me give you one more. Let's talk about the dimension of, let me say surface tension. Surface, sur, surface tension. So what is the dimension of surface tension? The formula for surface tension is force over length. Take note of that. Remember I told you before you can get any dimension, you need the formula of that quantity. The formula is what? Force over length. So what is the formula for F? For dimension of F? M L T minus 2. Why this one is L? So here, when you solve this, L cancel L, you can see that L cancel L, then what you have is MT minus 2. So let me give you this and give me the answer in the comment section. What is the dimension of viscosity? Viscosity.